looking up at the sun, and it's 12 o'clock noon, right? But so unless you can touch it and measure it and know what you're looking at, you don't know what you're looking at. You're interpreting what you're looking at. So if the sun is there at noon and at 1 o'clock it's there, the question I have to you, is the sun below the horizon or beyond the building?
Just beyond the building.
Just beyond the building. Very good. So here's our perspective grid, and here's our guy. This is his eye level, and we put a mountain in front of him. Let's say the top of the mountain is 3,000 feet above him. Flat or globe, doesn't matter. The mountain is 3,000 feet above him. The sun moves away below the horizon or beyond the mountain. Simple.
Beyond the mountain.
Beyond the mountain, just like it went beyond the building. So if we move him backwards, like 25 miles, the top of that mountain will look like it's at his eye level. Globe or flat, that mountain is still 3,000 feet. If it's a globe, 2,980 feet, whatever the curvature is at that distance, right? Right? So it's still above his eye level. So when the sun goes away, does it go below the horizon or beyond the mountain?
Just beyond the mountain.
So that's your terrestrial horizon that looks like it's at your eye level. It's 3,000 feet above your eye level. But now if we add clouds in there, what are the clouds doing? Are they going down or are they just going to the vanishing horizontal eye zone? And the sun goes beyond it again. So the sun is a terrestrial object. The sky, the clouds and the air, if there was no clouds, the air becomes opaque over distance. Just like if you and I were standing looking at each other, I had a perfect piece of glass, you couldn't even see the glass. But if I had 10 pieces of glass, it'd be a little harder to see through. If I had 100 pieces of glass, we couldn't see each other, right? And at a point, light won't even go through that. And that's what the atmosphere does. So now this line here, it's not 3,000 feet above your eyes. It's plus the height of the clouds. That might be another 10,000 feet above your eye level. So did the sun go below anything or did it go beyond something that's 10,000 feet over your eyes?
Yeah, beyond something that's 10,000 feet over your,
right.
10,000 feet over you.
So no matter how many times you show this to a dishonest glober, right? They'll say the sun could never do that. And here the camera's obviously below the table. And flat earthers should say, no, it's even with the table. And then they'd zoom in. When you zoom in, you're opening up the iris. And you could argue that as the iris gets bigger, it can see over the table when you zoom in, right? And bring the coin back in, right? And that's okay. I accept that argument. But if you're below the table, it'll disappear just like this. And this line here is your horizon. I say that's 10,000 feet above your eye level, not at eye level. But the horizon always appears to be at eye level. To show you guys two tables. Are these the same width and dimension?
Well, I know.
You know.
Yeah, no, I've watched your stuff.
Okay, so again, so your eyes, it's very difficult. So this is just showing you that unless you can touch it and measure it, you can't really tell. So first, let's you guys, you probably have seen this, but I want to show it again because then I'm going to lead into something new that I'm going to show. Have you seen my flat Earth kitchen? Seen this?
Yes, I've watched your video on this.
Just real quick so people can see it. We're looking.
This is for our guests for sure.
We're looking at the sun from the elevation of the sun. This line is level. Yes, it's level. I verified it in the full video, but you can see that it's level. Here's my counter. Here it is moving along. This is it can be a cloud deck or a mountaintop, whatever. It's opaque and it's above it. Now we're going to look at the view of the same path from the table, from the far end of the table, and look at the line. It looks like it's going down. If I showed you this first and said, is this line level? You would say, no, it's going down. And look, it never went below this, but this is from the viewer's point of view at your eye level. This is compressed into the horizon. Look at the line now. It's almost going straight down. Okay. So this is just without any atmosphere, refraction, magnification, nothing. Okay. Now we compare it to a real sunset. And look, it goes behind, this is the real sunset, an atmospheric deck. So this is that cardboard bottle thing I had, right? Yep. But your eyes can't see the difference between that line and the apparent horizon. And it all crunches together and it all just disappears beyond this cloud deck, atmospheric deck of opacity. So now we're going to talk about perspective. So when you watch something go away, it gets smaller. Bam, it just goes away and it gets smaller because you are at the same level as that thing. As it goes away, it gets smaller. Nobody disagrees with that. So this is perspective, and it literally goes away until it disappears. Now these lines are all level, but look at these lines here. These are almost going straight down. Okay, this is a hallway. And it's level, but your eye perceives these as going down. So here we have a sun that's already elevated. Okay, it's really going straight across, but due to perspective, it goes down. And this is what an observer would see. This is like a cross view of it. And this is what you would see. So this sun is just going down due to perspective, like I just demonstrated. Okay, so I forget what the name of the effect is. So here are the train cars. It's already reduced.
Yeah.
And as it goes away, it really doesn't change size very much. So this is a cartoon. Let's look at it in reality. Here's two balls, okay, that are the same size, 6 feet apart. The one in the distance is way, way, way small. Okay, so we have a camera looking at it. One's very close, one's very far. It shrank already, as things do as they go into the distance. But when we lift the camera up, straight up, not getting any closer to the other one, watch what happens. Okay, because when something is already away from you, its perspective drop gets less and less. And at 7 feet high, they're pretty much the same size, right? So if I move this ball along the track, it's not going to get any smaller. And perspective tells you it's going down. Okay, this is all just a trick of the eyes.
Yeah,
and that's how it works. Now, here's another thing. There's two more things I'm going to tell you. One, as that sun is going away, as it becomes lower and lower, you're looking, like when you're looking at the sun above you, you're looking through just a little bit of atmosphere. But when you're looking at the sun away from you and it's already dropped, you're looking at it through all of the atmosphere. And when you're looking out over water, there's moisture in that air. So as the sun is going away, remember, it's already up. It's not going to get much smaller. It's also being magnified a little bit sometimes, not every day. That's why sunsets look at different sizes on different days. Okay. It's called atmospheric magnification. That just plays a little part. And then the last thing is, it's really not bigger. When you see, the next time you guys have an opportunity to see a moonrise or moonset that is gigantic on the horizon, well, you go, wow, that's big. It's not. It's the same size as this one above you. And the way to do it, you know, you think like, wow, look at that moon. You take a picture, and you look at the picture, and go, oh, it's tiny, right?
Yeah.
But you look at it, it's gigantic.
Huge,
it's your mind. Here's what you do. Sounds gay. It's not. Turn around, spread your legs, bend over, and look at the moon upside down through your legs, and it will be tiny.
You're kidding me.
It will be tiny.
Why?
Because your brain short circuits and it can't.
Oh my God.
It's totally a short circuit. It's the way we see things. We don't see. Yeah. So the whole argument of the sun not getting smaller, and by the way, it does get smaller many times. Depending on the.
Try it out later.
Yeah. Is it a full moon?
No, it was a few days ago.
Yeah. So, well, it might be big enough. But this was taken by a soldier in Afghanistan, super dry, not over the water, and no humidity, and the sun just goes away. Paul McCartney knows the fool on the hill sees the sun going down, but the eyes in his head see the world spinning round. And this, look, we are spinning backwards at 1,000 miles an hour.
Yeah.
Why isn't that sun going down? It's just going away, and it's getting smaller and smaller and smaller until you can't see it anymore. Okay, so.
And then you zoom in, and then you'll see it again.
Well, here's one. Looks like this one's setting over the water, right? But as I showed you before in my kitchen one, you can't see that there's space between the sun and the water. And when you zoom in, because, you know, these clouds over here are the same height as the ones above you, but when you zoom in, oh, look, it's not touching the water. It's still up there. And then over distance, like right here, it becomes opaque, and the sun will just go behind that. And it looks like it's going down. It's not. We showed you that with the perspective. And it looks like it's disappearing behind the horizon, but it's not. There is no physical horizon. We can see too far. It's all nonsense. Next.
Okay, now check this out. Here we have two lighted balls representing the sun or moon. One of them is close and large, and the other is far and small due to perspective. Now you will notice that the two balls are at eye level, and as we drag one away, it reduces in size quickly and matches the farther one when it gets there. This is just due to simple eye level perspective. Now we are going to raise the camera straight up, not getting any closer to the far ball, and you will see that both balls have reduced in size and look fairly close to the same size. As we move the closer ball away again, you will notice how it does not shrink much due to perspective. The phenomenon you're witnessing is called foreshortening in art, or more technically, it's an effect of angular perspective compression or diminution of apparent size. So the next time a globetard says, if the Earth was flat, the sun would shrink as it moves away, you can ask them if they know what foreshortening or angular perspective compression is, and flat smack that smug know-it-all look right off their face.
সীমার বাইরে চলে যায়। এখানে আরেকটা সূর্যাস্ত আছে। এটাও একই রেখা বরাবর চলে যাচ্ছে এবং শুধু আমাদের চোখে দেখা যায় না, দৃষ্টির সীমার বাইরে অদৃশ্য হয়ে যায়। এটা আসলে বায়ুমণ্ডলের অপাসিটি ডেক, যেখানে বায়ু ঘন হয়ে সবকিছু আড়াল করে ফেলে, এর পেছনে চলে যায়। যদি আমি এই লাইটগুলো রেখার উপর বসাই, তারপর সেটা একটু ফেড করি, তাহলে অবাক হওয়ার মতো ব্যাপার, পুরোপুরি একই জিনিস দেখা যায়। যেমন করিডর সমান, সাগর সমান, লাইট সমান উচ্চতায়, সবকিছু সমান দৃষ্টিকোণ অনুযায়ী দেখা যায়। সূর্য দূরে যেতে যেতে একইভাবে দৃষ্টির কারণে নিচে নেমে যাচ্ছে বলে মনে হয়।
So we can see too far, right? If we live on a ball of 24,901 miles around, there is a physical curvature. At 3 miles, you shouldn't be able to see the surface of the water anymore because it's below the curve if you're 6 feet tall. If you're lower, it's even closer. If you're a foot off the ground, it's only 1.22 miles away. But we can get a camera and zoom on things 10, 15, 20 miles away and still see them, right? For example, this is a spot in Alouge, France, and from this viewing spot, Mount Canigou is out here 175 miles away. Well, according to the globe math, using the globe curve calculator, the top of that mountain should be over a half a mile below the curve, right? Well, we don't see it. Interesting, okay? The light from the mountain isn't bright enough to push through 175 miles of atmosphere. Just like if you're in a big pool, you can't see the far side of the pool just because the water becomes opaque. Air does the same thing over a greater distance. But twice a year, the sun migrates in between the two tropics. I'll show you that in a moment. When it lines up with that viewing spot, the sun's light is powerful enough to push that far, and it backlights the mountain. And here is the entire mountain, okay? The top of this mountain should be a half a mile below a physical curve, but it's not. It's right there, okay? This is just one of many, and the other one they've indoctrinated us with is they say boats over the horizon. We've seen the sun as a local light and it takes its light with it. So when it's out here going much faster in December, everyone in the world experiences faster sunset to dark. And when it comes all the way in June, when it comes all the way in, everyone has a longer lingering light because the sun is moving away slower, right? When I talk about lingering light and taking its light with it, let me show you a quick sunset. Where is it? Where is it? There it is. Okay, so this is me with my drone, and the sun is up high in the sky. And if we were on a ball, it would just go down, 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 and it would just keep on going, right? And it would always go at the same rate, 15 degrees per hour, okay? Mm-hmm. But it's super clear day, super cold, no humidity. The sun went down, 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 and it stopped. And it just sat here above this apparent horizon. right? It's out here. This is sped up 2,500 speed. Okay. What's going on? I'll repeat over here. Okay. It just didn't have the power to push through anymore. So it took its light with it. Its light is local, the local light, and it just went away. Now, when I put this up, man, the trolls went crazy. You're Photoshop, this and that, blah, 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 right? So I did it again, and I did it again, and I live streamed it, okay? And I have the high def files. People are like, well, how come no one else has ever seen this? How come you're the only one? I go, well, at the time, I may have been the first, because to do this, one, it has to be a super clear day. Very few of those with all the stuff that's going on in the sky. Two, it has to be no humidity, so it has to be below freezing, basically. Three, you have to have a drone with a 4K camera and be willing to heat the batteries so they don't freeze, and send it up and watch the sun when it looks like it's already almost gone. Okay. And then you have to bring it into your editor and zoom in on that tiny little area so you can see what's going on. Okay. And so I'm the only one crazy enough to do that. Now, a lot of people have done it. It's been done a whole bunch of times. There's a whole section on the app that'll show you a whole bunch of these.
Where does the sun go if the earth is flat?
Well, the sun neither rises nor sets, but travels in a clockwise circuit from east to west, and only appears to rise and set due to perspective. The sun disappears at the vanishing point of human perspective on the horizon, where the ground meets the sky, and since the sun is not 93 million miles away, I repeat, not 93 million miles away, but much closer and smaller, the light emanating from the sun only illuminates about half of the flat plane at once as it makes its daily journey.
Fukuji. You see? The sun is not setting, it's traveling away. See what happens? The sun does not.
U.S. soldier in Afghanistan. In such an arid environment as the desert, where atmospheric lensing is minimal, you can clearly see what is actually happening at dusk. The sun gradually gets smaller.
Now, many people say the sun should diminish in size and vanish into a tiny dot as it gets further away. But that is not how perspective works, okay? Because we know horizontal parallel lines converge at the horizon. For them to be correct, Cash's eyes would have to be at the same altitude as the sun. If this were the case, then yes, Cash would probably see the sun diminish in size into a tiny little dot until it disappeared. But obviously, we are well below the sun, so we see it go in a downward direction. Now, this video is a time lapse of the sun setting from an airplane. Being in the airplane at over 30,000 feet, this pushes our horizon back extremely far, allowing us to see a greater distance. From this altitude, it becomes more apparent that the sun does diminish in size as it gets further away until it hits the horizon, at which point it completely vanishes. This is exactly what we should expect to see. There's no reason we should expect to see the sun continue to diminish in size until it vanishes.
Hello everybody, P-Brain here. I got inspired to do a video. I've been discussing on my couple of my videos about this notion that the sun would never make it to the horizon. And I've had a couple people show me diagrams, and I haven't come up with a really good illustration to completely debunk this idea. Until now. So that's why I got inspired to do this video. First of all, let me just say I don't know how high the sun is, so I'll just go with the 3,000 miles that many flat earthers use, and that's what I'm going to use for this video. This guy sent me this picture, and he's got all the maths included, and it looks good, you know. At first, I had a little tough time with it because there's a couple things true about it, right? It's showing the sun traversing over the ground, over the flat earth, and it's parallel to the ground. So it had that going for it. And it's showing that when the sun is further away from you, it angles down, just like perspective. Same as this guy, Daz the cameraman or something is his name. He has a video out and he shows this picture. And it's the same thing. It still shows a parallel sun to the ground. And instead of moving the sun, he's moving the observer. But it's the same diagram. If you flip it upside down, it looks like identical. Anyway, so it's the same notion. So I was a little bit perplexed. I was like, wait a second, you know, makes you start to doubt. But I mean, I know it's wrong, but I was like, wait a minute, it's got perspective. It's so I thought. And then it hit me. What's wrong with this picture? What's wrong with this picture is that they are attempting to calculate visual angles to the sun from a non-visual, non-perspective drawing. So the drawing is not taking the visual perspective of the observer into account, and that's what's wrong with this diagram. You see, you cannot calculate visual angles to convergent positions, which is where the sun is from the observer, by using non-convergent parallel lines, which is what they're doing in the diagram here. They have two parallel lines and they're drawing visual angles to it. It's true that this drawing is an accurate representation of actual relationships and positions of the observer to the sun, but It's a non-perspective side view representation. So this diagram is not accurate at all as it relates to the perspective of the observer. So if we add perspective lines, we get a completely different picture. All right, take a look at this wall of lines. Now, this wall is not an illustration, it's not a cartoon, it's a photo. It's reality, okay? This that they put up here, although it has a lot of truth, in it, showing the parallel sun and all that, it's nothing but some geometry. I mean, they're showing us some angles, but it has nothing to do with perspective and how we would see the sun. So, it's bunk. So in this next slide here, I'm going to superimpose these lines, the perspective lines, over on top of this. Okay, here we go. All right, and as you can see, the way they're representing the sun as staying parallel to the ground is not correct. The sun would follow these perspective lines, and what they really are is spatial planes, right? They're invisible spatial planes that are around your z-axis. Now your z-axis goes from your eyes, a straight line out from your eye in any direction. Okay, that's your z-axis. So anything parallel to that will start to converge toward that focal point or the horizon, right? In line with that z-axis. Everything does. Any lines going away from you are going to all converge. Yet this diagram that they show us, saying that these are the visual angles to the sun, have no convergence. The lines are parallel. See, look at these parallel lines and look how they converge. They completely go against this geometric drawing or these angles and these formulas. They don't work, friends. So anytime someone brings this up, bring them to this video, show them this picture, and this is the reality. The photograph is a reality. That's how we see everything. So this representing the sun is going away from you parallel to the ground, and then calculating your angles to the sun based on that is wrong, and it doesn't work. Okay, and quickly notice with this line of converging parallel lines or planes. Notice how the higher up they get, or the further away they get from the yellow line, which is your z-axis, notice how they orient themselves more and more vertically and less horizontally. Also notice how all the lines converge at the same point, the vanishing point. It doesn't matter how high they are, they all go to the same place, which, interestingly enough, means that no matter how high that object is going away from you, it visually goes to the same place. Okay, here's the wall of lines again. Notice that these are true perspective lines. These are parallel lines, but from the observer, which is this little guy down here, this is what these parallel planes or parallel lines would look like. They just happen to be represented by these wooden planks, right? But that's actual perspective. What they represent as the sun up here traveling parallel to the ground is not perspective. Yet they are calculating angles based on a non-perspective drawing, right? Their maths are based on non-perspective lines, right? Two parallel lines. Well, you can't, because that's not the perspective of the observer. The observer sees these lines, the converging lines. So as you can see, this is the
practical demonstration of पर्सपेक्टिव की वजह से ऐसे ग्राउंड में जाता हुआ नहीं लग रहा है. दिस इज नॉट ड्यू टू पर्सपेक्टिव. तो क्या है, ग्लोबतर इसको पर्सपेक्टिव क्यों नहीं मान रहा है, आसमान को पर्सपेक्टिव क्यों नहीं मान रहा है, रूप को मान रहा है, पर्सपेक्टिव की वजह से हो रहा है. जब आसमान की बात आती है, जब तारों की बात आती है, जब सन मून इस सब की बात आती है, तो बोलते हैं उसमें पर्सपेक्टिव काम नहीं करता है. क्यों काम नहीं करता है? बोलता है कि ये बहुत 1000 मिलियन लाइट मतलब दूर में है, माइल्स दूर में है, लाइट ईयर्स दूर में है, इसलिए उसमें उसके ऊपर पर्सपेक्टिव. हम एक स्ट्रेट लाइन